Hello, I want to discuss first an easy problem using springs. This is example 3.4 in your book. And what we have here is this system shown here. So we have one cable and one spring. What's important here is that the undeformed length of the spring, which is described in your book as L prime AB, is 0.4 meters. What you need to remember, and maybe I used a different notation in the book, is the stretch. And I had said it like this. So it's the stretch minus the original, but then this would be the stretched as your notation in the book, and then this is the unstretched. Okay? So this is unstretched and this is stretched, and this is the notation that I used before. And the stiff constant of the spring is 300 newtons per meter. And what you need to remember is the equation here: the force exerted by a spring or on a spring equals the constant times the stretch. So this is the free body diagram. Here we have TAC, and here we have the 8 kilogram lamp, and this comes from the weight would be the mass times 9.81 meters per second square, and so this is 78.5 newtons. Okay, so here, and let me go to the next one. So here is where we have the spring, and I always like to show the spring there. So remember that then TAB is going to be equal to the spring constant times the stretch, and the spring constant is 300 newtons per meters times the stretch. Let me go back and read. So we have to determine the required length of cord AC. So first thing we do is calculate the forces. So we have the sum of the forces in X and sum of the forces in Y. And one thing that's important, whenever we have this type of system, point system, where we have all collinear forces, we cannot calculate a moment here. So because the moment as it goes through that point is always 0, so you cannot get an additional information from that. So the sum of the forces in X would be equal to, if we have right positive, okay, so we have minus TAC cosine of 30 plus TAB, okay, and this is what we'll have later. So this equals 0. And then we have sum of the forces in Y, and this is positive going up, is TAC times sine of 30 degrees, and then we have that's positive minus the weight, which is 78.5 newtons, equals 0. So we can solve this for TAC because that's the only unknown, and then replace in the top equation to obtain TAB. Okay, so let's do this here. TAC sine of 30, and remember I'm doing this the long way just to make sure that you understand everything. So TAC equals 78.5 divided by sine of 30, and TAC is 157 newtons. Okay, so now I substitute 157 and this is negative, so I'm going to substitute from that expression cosine of 30 degrees plus TAB equals 0. So now TAB equals 135.9 newtons. Okay? So if I go back here, let me just summarize the results. TAC equals 157.0 newtons and TAB equals 135.9 newtons. Okay? So this here is what I told you, like this expression here. Okay? TAB is going to be equal to KS, and K, we said it was 300 newtons per meter times the stretch, and equals 135.9 newtons. So then this gives me the stretch, which is equal to 0.453 meters. Now remember that the stretch is also, let me make sure I use the right notation, LAB minus L prime AB, okay, which is, you know, the unstretched, or the stretch minus the unstretched. Okay, this is the notation that I used previously. Now the stretch is 0.453 meters, and I don't know the stretched, but I know that this one was given, LAB was given as 0.4 meters. So now I can find what is the stretched distance, which is 0.4 meters plus 0.453 meters, so LAB equals 853 meters, which is the answer. Okay, so this is a 2D, and I hope you understand this. Remember, you can pause anytime. You can find another example for springs using 3D. Thank you.